Hey everyone, welcome back to XGENIA tutorial. Today we'll continue with the coding session for the payload in the function node. It would be useful to send and receive the actual message to the AI we are using. Now let's set the payload for this integration. Think of it as the good stuff, the main thing you're trying to send, deliver, or accomplish. If you send a message or request online, the payload is the actual data, the text, the image, the user's details. First, we define the endpoint. This is the specific web address, or URL, where we'll send our request. It's pointing to the Hugging Face router for chat completions. It creates a constant variable named endpoint, searches for its actual destination, a Hugging Face router endpoint for chat completions. Const endpoint declares a constant variable named endpoint that will store the URL. This URL is the main address for the Hugging Face inference API router. It's the central service that receives and directs all API requests. Then this is a placeholder. Its value will be inserted here to tell the router which model to send the request to. This part of the URL tells the API server exactly what kind of request this is. In this case, it's for the chat completions service, which is used for conversational AI. We define an object called headers. Think of these as the metadata that goes along with our request. It has two essential pieces. First, the authorization header, which uses the API key to prove who we are, like a digital ID. Second, the content type header, which tells the server that the request message is formatted as JSON. We create a new list called messages for API. We start this list by taking all the messages from the existing history and copying them into our new list using the spread operator, the 3 dots. This ensures we preserve the conversation context for the AI model. This is an if statement for safety. It checks if we have a system prompt set, and also checks if the list of messages doesn't already contain a system message. If both are true, we proceed to add it. If we need to add the system prompt, this is where we do it. We use unshift to add the prompt to the very beginning of the message list. We structure it as an object with the role of system and the actual text content of the system prompt. This is a conditional step. It checks if a system prompt is provided and if one doesn't already exist in the history. If both are true, it uses unshift to add the system prompt as the very first item in the array. Finally, we use .push to add the new message from the user to the end of our list. This message is formatted with the role of user and contains the actual text of the user message. This line creates the payload, which is the main package of data we're sending to the API. It tells the server 3 things: which specific modeler to use, the entire list of messages we just prepared, and that we want the response sent back all at once. Model ID. This specifies which AI model should process our request. The value of model ID, like ChatGPT or Gemini, is pulled from an earlier variable, ensuring we target the correct language model. Messages for API. This is the conversation itself. As we just discussed, the value of messages for API is the array we constructed, containing the system prompt, the full history, and the new user message. This tells the AI the context it needs to respond. Stream false. This sets a parameter for the response. Setting it to false tells the server, don't send the answer back word by word. Wait until the entire response is ready, and then send it all at once. This word try signals the start of a try. This is a crucial safety mechanism in JavaScript that says, try to run the code inside here, but if anything goes wrong, like a network failure or server issue, don't crash the whole program. Instead, jump to the catch block to handle the error gracefully. This line uses the fetch function to send the API request. We define a new variable, response, to hold the server's reply. This property specifies the HTTP method. By setting it to post, we're telling the server that we are submitting new data. This is straightforward. We're attaching the headers object we created earlier, the one with the authorization key and content type, to the fetch request. This ensures the server knows who you are and how to interpret the data you're sending. This line defines the body of the request. We take our payload object, which contains the model ID and all the messages, and use JSON, stringify to convert it from a JavaScript object into a single string of text. This is the format required to send complex data over the internet to the server. This line contains two things. The closing curly brace ends the object we were using to configure the fetch call's details, the method, headers, and body, and the closing parenthesis ends the actual fetch function call itself. After the server sends a reply, we create a new variable called response data. We use response.json to read the server's body and convert the raw JSON text into a usable JavaScript object. The await is necessary here because this process of reading and converting the data also takes time. ResponseOK is a built-in property that's only true if the HTTP status code is between 200 and 299, meaning success. The exclamation mark in front of it means not. So we're checking. If the response was not successful, run the error code inside this block. This line is used to set a variable that will hold any error message from the API. However, in a successful run, this variable is likely to remain empty or null. This is the final step in the error block. The throw keyword immediately stops the execution of the try block and creates a new error object containing our detailed error message. This is then caught by the corresponding catch block, allowing your program to handle the API failure cleanly without crashing. Let's continue by declaring a new constant variable, responses AI. This is where we're going to store the clean, final answer from the Hugging Face AI model. Now look at this chain. This is our safety feature. It checks if responses data exists, then checks for choices, and then tries to grab the first item in that choices array. If any part is missing, the whole chain stops and prevents a crash. We keep chaining. After getting the first choice, we safely check for a messages object, and finally, the content property. This content property is the crucial spot. It holds the actual text the AI generated for us. Now we connect the data to our XGENIA node's output ports. We assign our cleanly extracted AI text to outputs.responses from AI. We also pass the full raw API response data to another port, outputs.API response data. This is great for debugging or if we need to access metadata later. And just for completeness, we often pass the original user input or user messages through, so the next node knows what prompted the AI. Finally, we call outputs.success. In XGENIA, this is a command that signals the node has completed its task successfully and tells the visual graph to fire the next connected node. Now let's look at our error handling. The catch block catches any major network or parsing issue that occurred in the try block. If an error happens, we capture the detailed error message and assign it to an output port, outputs.errorMessages. This lets us visually display the problem to the user. Crucially, inside the catch block, we call outputs.failed. This is the opposite of success. It tells the XGENIA graph to follow the error path you've defined, showing an error message on UI instead of the AI result. Before we leave, we have this conditional check. This is our input validation gate. All right, the payload is set. Surely, you can use AI to help you do the JavaScript, but this tutorial will help you understand the logic behind each line you need to write. Thanks for watching. Get XGENIA for free today at xgenia.ai and start building smarter and faster than ever.